All right, so at this point, we've seen a lot of different properties, and now I want to go through and we're going to have one page that summarizes everything we've seen so far. So instead of having to flip through all of your notebook pages to find each of these different properties, we're going to have them all in one place. All right, so I want you to locate product of powers. Should be the top middle. Okay, so product of powers, we have a product, which is multiplication. So multiplication of powers. Let's see if we can get connected here. There we go. So multiplication with powers. So that means that I have two powers and they're being multiplied by each other. Okay, let me make this a little more clear. Now the thing about these properties, don't forget that we're looking for a common base. So for each of these properties, the base has to be the same for these rules to work. So if I have a to the b times a to the c, that equals a to the b plus c. So if you have a common base that we're multiplying powers, you add the exponents. So remember, product means we're multiplying. Don't forget we have to have the same base. And you do have room to add extra little notes too. So we do know that they must have the same base. And that's actually going to follow the product of powers. And down below is quotient of powers, so you can draw an arrow. That's the next one we're doing. You might as well draw those now. So here's an example. 4 to the third power times 4 to the sixth power equals 4 to the 3 plus 6, which equals 4 to the ninth power. Now when you're working through these, you can skip the part where you show the 3 plus 6. So ultimately, you could have this as your work. Okay. Next up, quotient of powers. So again, just like the product of powers, we must have the same base, but now we're dealing with a quotient, so we're looking at division. So if I have a to the b power over a to the power of c, we subtract the exponents. Remember, a way to kind of help you keep track is a quotient. Division makes a number smaller. Subtraction makes a number smaller. So if we're dividing our powers, we subtract. So the process kind of holds true for the rule. With product of powers, multiplying makes a number larger, so does addition. So those go hand in hand, right? So for an example, we could have 2 to the fifth power over 2 to the third power. And that would equal 2 to the 5 minus 3, which is 2 to the second power. And again, you can skip this middle section. That's optional. All right, next up, zero exponent. We just saw this, and for this we know that all numbers with a zero exponent equal 1. And our example would be 12 to the power of 0 equals 1. Always equals 1. Next up, negative exponent. So this one you'll want to write a little bit smaller up here because we have the two different things I want you to take a look at. If we have a to the negative power of b, remember we're looking at a reciprocal, so instead of my power in the numerator, it goes down to the denominator, and my exponent becomes the opposite. Now we have a different situation that could happen. You could start out with your power having the negative exponent in the denominator. Again, we find the reciprocal, so instead of the power being in the denominator, now it's in the numerator. Negative b becomes positive b. We're also going to do two examples, so definitely write that as well. So let's say 4 to the negative second power becomes 1 over 4 to the positive second power. 1 over 8 to the negative second power becomes 8 to the positive second power. So remember, the position of the number or the power becomes the opposite, or they switch positions, so the numerator becomes denominator, denominator becomes numerator, and then the exponent becomes the opposite. And that's it. Now for this last part, we talked about one portion, but there are actually 3 types of things you'll see, and we never really covered these separately, so I want to do that now. Okay, down at the bottom, you'll see power of a power rules. So these 3 rules, it can be broken down into 3 separate sections. The first one, and this is the one that we specifically looked at, was power of a power. And this is if we had a to the power of b to the power of c. So this was a power to another power. And what we did with this was we had a, when you have power to a power, it's kind of like the outer power distributes inside. And so you get a to the b times c. Or actually, let me say c times b, and you'll see why in a few minutes. Okay, so for example, if you had 2 to the 3rd power to the 4th power, you would end up with 2 to the 12th power. Okay, so now we're going to practice putting our power properties together to simplify expressions. So you're just going to copy these notes down in your notebook. So we're going to take a second, and there are some steps that are pretty safe to follow when you're simplifying these expressions. There's some things that you should look for first, some steps you can take that will help you simplify these efficiently. So we're calling them steps to simplify expressions using properties of powers. So your first step is going to be to simplify all negative exponents. So that can handle a lot of issues, is to get rid of your negative exponents from the very beginning. You could wait, but sometimes it makes things a little bit easier. Step 2, now this one applies if you have a fraction situation. So first you'll simplify the expressions in the numerator if possible, then simplify anything in the denominator if possible. So these are just some things you can kind of run through in your expressions to help clean them up while you're simplifying. So if there's a fraction, look at the numerator, see if there's anything you can simplify, then look at the denominator and see if there's anything you can simplify. And third, simplify what's left. That's when you can start using those power properties to, subtract exponents or add exponents, powers of powers, those type of things. So pause and get that copied if you didn't copy that already. So let's take a look at a first example. N to the third power times 5, n to the second power. So the first thing we look for are negative exponents. We don't have any. Then we can see if there are any fraction situations to deal with. We don't have that either, so that's nice. So now we just simplify. Now what you'll notice is I have n to the third, then 5, then n to the second power. Now my 5 is not to the second power, just the n. The 5 is not the base. So what you saw me do is I made 5 to the first power. And then I'm going to rewrite with my bases of n together. So I get n to the third times n to the second times 5 to the first power. So I just used the commutative property. Then we'll use our power property to simplify. N to the 3 plus 2 becomes n to the 5th times 5. So again, don't forget that that 5 is not part of the base that's to the second power. It's to the first power. Then we rearrange so our common bases are together. Then we can follow those power properties. And those little explanations to the side, that's optional if you want to write those down. They just kind of explain what we did. Example 2. M to the second power over 5m to the third. So again, we want to check for negative exponents. We don't have any. Then let's look for fractions. We do have a fraction. However, if we have a fraction, we want to see, can we simplify the numerator? And there's really nothing to simplify. And then we look to see if we can simplify the denominator. And there's nothing to simplify on the denominator. So now we're going to see if there are any properties that we can use. So we'll simplify using the quotient of powers. Now what you need to notice, though, is my quotient of powers deals with my base m. That 5 on the denominator is not to the third power. 5 is not grouped with the m. So what I did was I wrote a 1 up in the numerator just so that you could see that I could split this fraction up into 1/5 times m to the second over m to the third. The 5 is not related to that third power. So once I break those up, I can use my quotient of powers rule to subtract those exponents. And we simplify and we end up with a negative exponent. And with that negative exponent, now you have some more simplifying to do. So just so when you think you're done, you're not. So hit pause and make sure you go through and see how all of that just happened. Because we ended up with a negative exponent that I now had to take one more step to make positive. 1 over 5m. Example 3. v to the third power to the second power. This is an easy one. We're looking at a power of a power. Multiply our exponents, and we get v to the sixth. And finally, example 4. So we have 2x to the third times 6x over 7x to the fourth. So again, we look for negative exponents. There are no negative exponents. Now we want to simplify the numerator and simplify the denominator. And that's a 6, by the way. So again, we want to separate our bases so that we can simplify that numerator a little bit. Keeping in mind that the 2 and the 6 have nothing to do with the x's other than multiplication. So those are reached to the first power. So what we want to do is rearrange so that I have my constants or my numbers multiplied and my x's. So on my numerator, I have 2 times 6 times x to the third times x to the first. When I simplify, I'll get 12 x to the fourth, because we're adding those exponents. Remember, if we're multiplying the same base, we add the exponents. And once I've simplified the numerator, there's nothing left in the denominator to simplify. So now I can look at my expression, and I get 12 over 7 times x to the 4 minus 4, because when we're dividing powers with the same base, we subtract exponents. And once you subtract those exponents, you get x to the 0 power, which becomes